Imagine a person needs to solve a jigsaw puzzle. They know the area of the puzzle, but not the shape. Each jigsaw piece has a colour and a number. The columns must have certain colours and the rows must have certain summation. There are 250 rows and 52 columns. If the summation is breached, they can receive a fine from the local government. If the summation is too low, they don't meet their KPI. They wake up every week and have to solve this problem in an ad hoc way because the pieces of the jigsaw keep changing. This is hard, so they create version after version of spreadsheet where they track the jigsaw pieces and use their knowledge of the pieces to find solutions in a greedy way. The spreadsheets help, but their strategy doesn't work if the jigsaw is infeasible in the first place. I know you are thinking, I can solve this with mathematical programming, and you would be right. But is that going to be enough for our jigsaw puzzler? Often, the mathematical model or algorithm is not the hardest part, but delivering the model as a part of a solution in a cost-effective, timely way that encourages the stakeholders themselves to become evangelists of the tool you have created. In this video, we will give you 5 tools to help you deliver optimization in practice. To help us tell this story, we want to share a case study with you about water optimization in Australia.
In Australia, water comes from 3 main sources: the rain, the ocean by desalination process, and groundwater. In this case study, we are going to talk about the process to remove water from the underground aquifers, process called groundwater abstraction. The aquifers are spread across the country, and some areas are logistically and geologically better than others for abstraction. For the same reason, each aquifer has their own quality profile, and the bores are the way we access water from the aquifers. Each bore differ each other due to flow capacity, quality, and age. To remove the pollutants from the water, it is necessary a series of processes. Each one has limits on the concentration of pollutants that the treatment plant can handle each time. For that reason, choose the right combination of the bores, called in this project as a blend, is important to enable the treatment plant to perform it best. This project we were concerned to define the optimal schedule of the bores, which means define which bore abstract, when start abstraction, and for how long in order to satisfy demand, operational limitation, and not violate any environmental regulations, such that we maximize water production. Our differential was to add a blend component into the model that keeps water blend under the treatment plant quality limits over 6 pollutants. In addition, we were concerned to incorporate the operational strategy into the model by embed the bore maintenance calendar and the plant shutdown period into account.
Some hurdles that you may face in a project include that the user themselves might be skeptical of the methodology you're choosing. The data itself might be inconsistent or easily misinterpreted without subject matter knowledge. Problems can involve complex business rules and edge cases that aren't immediately apparent. This is why we recommend a user-focused project. The stakeholder, who will be the user of the algorithm, will have the power to make your solution redundant simply by not using it. On the flip side, if you can fully engage the user in the project, they can become an evangelist and spread the good word about your work. You can achieve this by involving your stakeholder throughout the entire process of building and testing the algorithm. For example, you can aim to deliver partial results as a spike, which means that you deliver something the stakeholder can use and test. This helps them to understand the tool you are building and gives them something tangible to give feedback on. Try to keep your implementation flexible for user input. This can be as simple as allowing the user to activate or deactivate constraints of the model, depending on the scenario. And ensure that you provide a good way for the user to explore and see a visualization of results of the model.
Our starting point for this project was a background research and process mapping to fully understand groundwater abstraction and the user necessity. Also, we did make sure that we communicate our progress by spiking into the business our implementation and the challenges that we faced. The user acceptance test was important to validate the core of the mathematical model and capture the user requirements. As a result, we did add few more components to translate more efficiently the fluctuations of the process. Our focus was on the user design, their interaction with the model, and how the solution visualization would add more value to the business. In addition, through the implementation, we had to develop our solution architecture and test different mathematical solvers to ensure we deliver the right tool to the user.
The problem that needs to be solved isn't necessarily what the user understands the problem to be, and this can make it easy to model and solve the wrong problem. To get around this, we recommend doing process mapping. A process map captures the steps taken to complete a task or process. It captures inputs and outputs, for example, triggers for events and documents. In many ways, it is similar to an algorithm, but there are formal flowchart-like components. You can use this to capture the user's process and to understand what you can do to improve their process. We recommend that you ensure that your solution doesn't add more steps to the process. In the end, the user should approve the map. The act of developing a process map is helpful in understanding the problem and showing the stakeholder that you also understand the problem.
During the first stage of our project, we did investigate how groundwater abstraction is defined, their impacts, triggers, input, and output. But to have a full picture of the process, it is necessary to talk with people not directly related with the process. So we did. As a result, we could define which set of negotiations were required to define the production profile, which gives us the demand fluctuation each week of the year and the flexibility that input has. We also could understand how the regulations take place in this context and define the impact of over-abstraction into the business. After this initial investigation, we conclude that groundwater abstraction is a component of a much bigger problem, and their optimization also benefits several areas. A key concept of groundwater abstraction is the bore schedule. This is a set of bore that will be scheduled together each week such that we satisfy the demand and the regulations. Historically, this has been done by weekly basis, by selecting the available bores up to the point we reach the demand, and then we calculate the quality of the blend. If the concentration of the pollutants is too high, a new set of bores has to be selected. But if this concentration is too low, that means in the future the abstraction process might be compromised. As you can see, this method generates several loops, all done manually, and the user only stops when they find a feasible match. However, this method does not measure the impact of this blend in the future, and even less if this blend is the optimal or not.
And how do you give the model or algorithm to your user? It isn't reasonable to assume they can install Git, pull your model, and run it from command line. What you need is a solution architecture, which is the design to deliver the solution in the context of the technology stack available. You should consider where the data will come from, where the model, solver, and algorithm will run, and how they will be triggered, how the results will be stored, and also how the results will be ingested into a report or visualization for the user. Your goal is to find a design that is as automated and persistent as possible, while being user-friendly and cost-effective.
This is our solution architecture. To allow multiple users to the model and not restrict to a singular machine, we choose to work with a virtual machine. So as a consequence, several users could have opportunity to get benefits from optimization. We also create a Power BI visualization dashboard to translate the solution and indicate the impact of this solution into KPIs. For example, plant capacity. And for us, developers, a version control was essential because we could develop different versions of the model and merge it later for a better performance. To finalize, the database component, in our case SQL, was important because it did hold all components together, and we believe this is important to persist of solution.
Mathematical programming can't easily capture qualitative and dynamic rules and is fairly rigid at the model definition step. The user will often want more than one solution, such as a solution pool or the ability to perform scenario testing. We try to offset this rigidity through flexible implementation. We write a wrapper to interact with the solver instead of coupling the implementation directly with the solver. This allows us to change solvers later without breaking the code. We also use object-oriented code style so that we can reference variables and constraints through objects instead of indexes. This reduces bugs and allows for simpler access to object attributes, which may represent the coefficients or other elements of the model. We use switches for indicator constraints to provide flexibility to the user. And we implement each constraint or variable in its own method to allow for different versions of the model, all controlled by switches. How do you convince the business that the project is worth running in the first place, or that the solver license is worth buying? If you are building a business case, which may be required if you want to purchase a solver license, then you'll need to measure the impact of your algorithm on the business. The easiest of these is direct value, where you take the current cost of operating, subtract the optimized cost of operating, and get the dollar value. Changing the solution may have indirect value too. For example, the cost of not having the solution, because it will lead to other ancillary costs. For example, you may have costly plant in place because you believe you need it, but through optimization, you may find that you don't need it anymore and you can retire it. Then there is value not measured in dollars. If there is any risk associated with a bad solution, you should put that here. I like to also think of the mental health of the people solving these problems manually, and the value derived from opening up capacity for them to focus on more important tasks. Finally, there are the new opportunities arising from the solution. This can be from new insights from the results, other ways the algorithm can be used in similar contexts, and new questions that can now be asked. These could form extensions to the project that utilize the tool already built.
The same as process mapping, the project value also requires much higher view of the process, and is quite often necessary some help of other areas of the business to define it. So why not use process mapping to help you in this journey? A good starting point is approach all areas that are indicating your process map. They will also give you some insight of other applications of this model. For example, we discovered that the same model that we use for groundwater abstraction could use to simulate the impact of the bore in a bore field if a bore collapse.
The jigsaw puzzler we talked about is a real person solving the abstraction scheduling problem. This problem had immediate impact on her because we were able to prove that the problem was infeasible from the outset. This saved her many hours of trying to prove the same through her spreadsheets. In practice, she now has a tool that she can use to solve many versions of the problem that weren't accessible to her before, freeing up her time to focus on more exciting tasks. Thanks for listening, and reach out if you have any questions, and happy puzzling.